Differentiation course series. So this is the first one going over all the basics of differentiation. Firstly, as a quick reminder, as these come in use later on, square root 3 of the x can also be written as 3x all to the power of a half, and 4 over x to the 5 can be written as 4x to the minus 5. So what is differentiation? Well, there's two core things it's used for. One is the rate of change and another is the gradient. So how do we write the derivative of an equation? Well, in the pink one, the main one you'll tend to see, if y equals something to the x, for instance 4x to the 6, then you'll write it as dy over dx, which means y with respect to x. Another way you may see it is as f dash x equals. And a third way you may see it, but it's less likely, I've not seen it over my time, but it depends on what you're studying, is y dot equals. But these two ways are the ways you're going to see it most often. So let's get to it. What's the rule? Well, if y equals x to the n, then dy to the dx, it's not just going to be x to the n, we're going to multiply it all by the power here. So it will be nx, but then we've multiplied everything by the power, so we want to take off 1 from the power. So our rule is the derivative is nx to the n minus 1. Let's apply that to these questions now. If we have y equals x to the 4, then dy over dx, or the derivative, is going to equal 4, because we're multiplying it all by 4, x, and then to the n minus 1, or the power, take away 1, 3, so 4x to the 3. For the pink question, dy by dx equals multiply it all by the power, so we've got 30x, and then take 1 from the power, 4, so we've got 30x to the 4. Two more questions now. Looking at the orange one now, we've actually got two sets of terms. We've got this 4x to the 6, and we've got this plus 2x here. And what we do with these is we take each part individually. So firstly, we've got dy over dx equals, the first part is multiply it all by the 6, which is 24x, and then take 1 from the power, which is to the 5, and then we'll deal with the second part now, which is just plus 2. The reason why the x variable goes, if we view the 2x as 2x to the 1, we'll times it all by 1, so it becomes 2x, and then take 1 from the power, which is 0. So it's the same as saying 2 times 1, which is just 2. So that's why we've got no x term there, it just becomes a constant. The green question will have dy by dx, so we're finding the derivative again, equals the first part, which is 15x to the 4, so we've times it all by 5, taken 1 from the power, and the second part is plus times it all by 2, and then we're just left with x to the 1, or just plus 2x. And finally, we've got the plus 7, which is a constant, so it actually disappears when we differentiate it. And the reason for this is because if we imagine 7 as 7x to the 0, which we've already said x to 0 equals 1, so if we just differentiate this on its own, we'll times it all by 0, so you've got 0 lots of 7x to the minus 1, which just ends up being a 0. So in essence, at the end here, you've got a plus 0, which as we know, there's no point in writing a plus 0, so we can just leave it off. So that's why constants are eliminated when you differentiate. Here's 5 questions you can have a go with yourself now. Pause the video and play it again when you're ready for the answers. Here we are, all 5 answers on screen. The only one I want to point out is question 5 and how you'd start that. Because we can just expand the brackets, which will end up being x squared plus 2x minus 8. Find the derivative of this and we'll find our answer of 2x plus 2. The next set of questions, we want to find the derivative of these, but you can pause the video and have a go yourself, but we'll go through these questions now for you. So firstly, we've got f of x equals 4x squared. So f dash x, or the derivative of the equation, is times it all by 2, so we're left with 8x. For b, we've got 7x plus 3, so f dash x will actually just equal 7. And finally, the last question, which is a little bit trickier, I'm actually going to rewrite it into a nicer format to y equals x to the minus 1, because that's the exact same, it's just a nicer way of writing it to be able to differentiate. So therefore dy by dx equals minus 1x to the minus 2. But we're mathematicians, we're lazy, we want to write this in a much nicer way, so it equals minus x to the minus 2. Finally, a bit more of a practical question. Calculate the gradient of the graphs at the given point. What you'll notice is all three equations are the same as the previous slide, but because we want to find a gradient at a given point, we need specific values. The reason why there's different gradients is because it's a curve, and that's why there's a variable in it, because the gradient is different at different points of the curve. So if we use 4x squared as an example, the graph might look something like this. And the gradient at x equals minus 2 will be around here. So in order to do this, firstly we need to differentiate. So f dash x equals 8x. So we've now found the equation of the gradient, but at x equals minus 2, we need to substitute the value of minus 2 in. There's 8 lots of minus 2. Therefore the gradient at 4x squared equals minus 16. For b, we've got 4x equals 7x plus 3. So we've got f dash x equals 7. And actually there's no variables in this one. So f dash of minus 5, or any of them actually, is just going to be the same, which is 7. The way to think of this one is like y equals mx plus c. So actually we've proven that this works. For the last one, c, we'll do the same again. So dy by dx equals minus x to the minus 2. We'll then substitute the value of x equals a half. So dy over dx, the value a half substituted in, equals minus a half to the minus 2. So dy by dx at the point x equals a half equals minus 4. And there's your final answer. And that's all for this differentiation video. Feel free to check out some of my other differentiation videos. The next one in this series is the high derivatives. Stay safe and healthy, and I'll see you in the next video.